This video is about fossil fuel systems. Fossil fuel systems refer to the vast network of extraction, refinement, distribution, and consumption processes that support the use of coal, oil, and natural gas as energy sources. While these systems have powered industrial civilization for over a century, they release greenhouse gases and other pollutants when burned, causing very substantial ecological damage. The Intergovernmental Panel on Climate Change, IPCC, the United Nations body composed of top scientists from around the world responsible for assessing the state of Earth's climate, has written, "Human activities, principally through emissions of greenhouse gases, have unequivocally caused global warming. Fossil fuel systems contribute significantly to this climate change and broader environmental degradation, issues that are critical to address in order to maintain planetary well-being." A specific example of these systems in action can be observed in oil extraction and its related technologies. Consider the process of offshore drilling, which involves the installation of massive rigs in ocean environments to access underwater oil reserves. These operations not only risk oil spills, which can have catastrophic effects on marine ecosystems, but also lead to the displacement and disruption of marine life. The 2010 Deepwater Horizon oil spill serves as a notorious reminder of the environmental risks inherent in these systems, underscoring the need to transition away from reliance on such technologies. Fossil fuel systems are deeply intertwined with economy, technology, and ethics, each affecting our path toward sustainability. The global economy remains heavily dependent on fossil fuels, with industries across sectors relying on their relatively inexpensive energy. Technology presents a dual role. Digital systems often consume substantial energy, while innovations in renewable sources like wind and solar offer promising alternatives to fossil fuels. From an ethical perspective, continued fossil fuel extraction raises important questions about human responsibility toward environmental stewardship. Addressing these interconnected challenges requires reimagining both technological systems and societal structures to better align with ecological boundaries. The technology underlying fossil fuel systems can be seen in the infrastructure of power plants and energy grids. Take coal-fired power plants as an example. These plants generate significant air pollution and greenhouse emissions, but also require huge networks of infrastructure for coal transport, often involving mining that destroys local wildlife habitats. Engineers and technology developers are working on energy storage solutions and grid innovations to better integrate renewable energy sources as replacements. Battery technology and smart grid systems can play major roles in reducing dependence on coal and other fossil fuels. The intersection of information technology and fossil fuel systems also highlights opportunities for change. Data analytics and machine learning can optimize energy use and reduce waste, aiding in the transition from fossil fuels to cleaner energy sources. Another area is the development of decentralized energy systems that use smart technologies to make communities more energy resilient and less dependent on traditional fossil fuel grids. These advances illustrate how technological innovation can help realign industrial systems with the long-term best interests of humanity and the planet, making these systems more sustainable, efficient, and responsive to ecological needs.